In this lecture, I am going to discuss about the basic concept of per unit system, or you can say how you will convert any physical quantity or power system quantity in per unit. Basically, when you will do analysis of power system in per unit system, then the analysis will be very simple. And for this reason, we usually do the analysis of power system in per unit. So what is per unit representation of any physical quantity, or how you will convert any physical quantity in per unit system? So this is the definition of per unit system. And according to this definition, the per unit value of any physical quantity is the ratio of actual value of the quantity to its base value. So if A is any physical quantity, and if you want, if any physical quantity in conventional unit, and if you want this value in per unit system, then according to this definition, you will have to take the ratio of its actual value to its base value. Suppose you want to convert current, which is given in ampere, and if you want to convert this current in per unit value, then what you will do, you will have to take the ratio of actual value of current to its base value. You will get current in per unit. Similarly, if you want voltage in per unit, voltage is given in volt, and you want to convert voltage in per unit, then what you will do, you will have to take the ratio between its actual value to its base value. So in this way, you can convert this volt in per unit or ampere in per unit. But you must remember that dimension of actual value and base value should be same, so that per unit value is a dimensionless quantity. So this is very important point when you are going to convert any quantity in per unit system. Then you must remember the dimension of numerator and dimension of denominator, or you can say the dimension of actual value and dimension of its base value should be same. What is base value? I will discuss this also. How you will select the base value. This is also a very important concept. And I will discuss this concept in next slide. So for this slide, you must understand how you will calculate per unit value of any given physical quantity. So this is the definition through which you can convert any physical quantity in per unit. And the second important thing is, if you will multiply per unit value with 100, then you will directly get value in percentage. Suppose current in per unit given 0.8 per unit. And if you will multiply this 0.8 with 100, then you will get directly its value in percentage. So in percentage, the value of current is 80%. So this is very important. You can easily get the percentage of any quantity if you have the value of that quantity in per unit. Just you will have to multiply it with 100. Now, the important thing is, what is base value? How will you select the base value? Suppose current is given I equal to 5 ampere, and the question is, convert this current in per unit. So the next thing is, what will be the base value? Because you will get current in per unit only if you have idea of base value. So the base value is very important. And in next slide, I will discuss how will you select the base value. So if you want current in per unit, so according to the formula, according to the definition of per unit, it will be ratio of its actual value to the base value. If you want to convert voltage in per unit, then it will be a ratio of its actual value to the base value. Here, the important point is the numerator and denominator should have same dimension. So the per unit quantity will be a dimensionless. Similarly, if you want to convert impedance in per unit, how will you convert? It will be the actual value of impedance to the base value of impedance. And as you know, the impedance is the complex sum of resistance and reactance. So in place of Z, you can write R plus JX divided by ZB. And you can separate these two terms. So you will get this expression. And as you know, the dimension of R and dimension of Z are the same. So this is a dimensionless quantity. And this R by ZB will be a R per unit. Similarly, this X by ZB will be a X per unit. So in this way, you can get the impedance value in per unit, which is equal to resistance, a complex sum of the resistance and reactance value in per unit. Similarly, if you want to convert, if you want to determine apparent power in per unit, then according to the definition of apparent power, it will be its actual value divided by base value. And as you know, the apparent power is the complex sum of active power and reactive power. So in place of S, you can write P plus JQ. And you can separate these two terms, you will get this result. And the dimension of P and SB are same. Though they are different in unit. The unit of P and SB differ from each other. Unit of P is what? And unit of S is SB. A unit of S is volt ampere. So in terms of unit, they differ from one another. But when you will calculate the dimension of watt and dimension of volt ampere, you will get the same dimension. So this is a dimensionless quantity. Similarly, in terms of unit, Q and SB differ from each other. The unit of Q is volt ampere reactive and unit of SB is volt ampere. So in terms of unit, these two quantity differ from each other. But when you will calculate the dimension of volt ampere reactive and volt ampere, you will get the same dimension. So this will be a dimensionless quantity. So numerator and denominator are of same dimension. So the term P by SB is dimensionless quantity. And you can write this dimensionless quantity as P per unit and this quantity as Q per unit. So in this way, the complex power or apparent power in per unit will be equal to the complex sum of active and reactive power in per unit. The main question is, how will you select the base value? Because without base value, you cannot determine the per unit value of any quantity. So it is important to understand the base value. How you will determine, how you will select the base value for any physical quantity. So what is base value? First point, you can see here, any round figure such as 10, 100, 1000, etc. can be selected as the base value. Depends on you. Suppose I am asking you a current through a machine is 5 ampere and convert this current in per unit. So you can take any base value. It depends on you. Suppose one student takes base value 10. For that student, the per unit value of current will be 0.5 per unit. But you must remember here, you must note here, if current is in ampere, then this 10 should also be in ampere, so that this quantity will be a dimensionless. This quantity should be dimensionless. And its answer will be 0.5 per unit. Suppose other student take base value of 100. So for that student, answer will be 5 by 100 equal to 0.05 per unit. So both answer are correct. This answer is also correct. But you have to mention the per unit value of this 5 ampere is 0.05 per unit if base value is 100. And for this, you will have to mention the per unit value of this 5 ampere is also 0.5 per unit, but if the base value is 10. So it is your choice on what ways you are going to convert the given physical quantity in per unit. So both answers are correct. So according to this, you can take any value as the base value. Suppose the question is voltage is 200 volt and calculate this 200 volt in per unit. So in per unit, the answer may be 200 by 1000 per unit, or answer can be V per unit equal to 200 by 100 per unit. Both answer are correct. This answer and this answer, both are correct. But this answer if base value is 100 and this answer is correct if base value is 1000. So both answer is correct. So according to this convention, you can take any value as the base value. But normally when you will solve the problem, normally what you will see, the rating of the machine is usually taken as the base value. So you must, this point is very important, and I will consider this, I also consider this convention. The rating of the machine, I will consider the rating of the machine as the base value. This is second concept. This one is the first concept. Both concepts are true. Either you can take any round figure as the base value, or you can take the rating of the machine or equipment as the base value. It depends on you. Usually in book or in research, rating of the machine are usually considered as the base value. Suppose in a problem, it is given a 3-phase induction motor rated as 500 kilowatt and 400 volt. So this is the rating of the machine. And according to this concept, you can take the rating as the base value. So in this case, power rating 500 kilowatt will be the base value for the power, and voltage rating 400 volt will be base value for the voltage. Similarly, if in problem it is given an alternator rated as this. So for this, the base value of complex power or apparent power is 5 MVA, because this is the rating, and base value for the voltage is 11 kV. So usually the rating of the machine is considered as the base value. So the both concepts are correct. Either you can select any round figure as the base value, and on that base you can convert the given quantity in per unit, or you can take the rating of the machine as the base value, and on the rating of the machine you can convert any given quantity in per unit. So this is the concept of base value. Now the question is, find the impedance of the machine in per unit. So according to second concept, you will have to take, it is not hard and fast rule, you can take the rating of the machine as the base value. And usually when you will see the rating or nameplate of the machine, you will see either complex power or voltage is given as the rating, or active power or voltage is given as the rating. Suppose if you will check the nameplate of the bulb, if you will see the bulb which is used in house, on bulb it is written 100 watt to 20 volt. When you will see the transformer, you will say on transformer it is written 1 kVA 11 by 22 volt. So usually either power or voltage is given as the rating, or apparent power or voltage is given as the rating of the machine. So generally uh, we select either power or apparent power or voltage, either active power or voltage as the base, or complex power or apparent power or voltage as the base, because this is given as the rating of the machine. So suppose the question is find the impedance of the machine in per unit. So according to definition of per unit system, the impedance in per unit will be its actual value divided by base value. So it is written here. And as you know from the Ohm's law or the definition of impedance, impedance is generally the ratio of voltage and current. So in place of ZV, you can write this and you can get this expression. And also you know, for a single phase system, the apparent power is the product of voltage and current. So from here, you can write current equal to SB by VB. So in place of current, you can write SB by VB. In place of current, you can write SB by VB. So you will get Z into SB by VB square. So in terms of rating of the machine, usually SB and VB is given as the rating of the machine. So if impedance in conventional unit is known, then you can easily find the value of impedance in per unit. So this formula is very important. Z per unit is equal to actual value of Z in ohm into apparent power divided by VB square. And this apparent power and VB is given on the machine. So this is the formula, and you must remember this formula. Later, I will use this formula to solve numerical example. Now, in next lecture, I will discuss some numerical example based on this concept. But you must remember this formula, because in next lecture, I will use this formula to determine impedance value in per unit. So in next lecture, I will discuss numerical example based on this.